So what is MATLAB? Well, the abbreviation MATLAB actually stands for Matrix Laboratories, so that's a good hint at the core capabilities of MATLAB. MATLAB is essentially a numerical computing environment, so something that is at its core just a mechanism for performing computations. Unlike other products such as Mathematica, for example, MATLAB does not have a front end, meaning that to interact with MATLAB, you essentially need to write text as you would if you were using a programming language. And in fact, that's exactly what MATLAB is, a very simple programming language combined with a large set of libraries and tools to help you perform various computational tasks. As a standalone product, MATLAB doesn't do that much. It supports some computation, including matrix algebra, and also some ways of visualizing data. But to get the full advantage of MATLAB, you really need to tap into its ecosystem of toolboxes, which extend the product both in terms of the kind of math it can support, the problem domains it covers, as well as the different ways in which computation can actually be performed. Since this course has to use some version of MATLAB, I'm going to use the latest available right now, version R2012B. The 2012 here refers to the year of release, and there are typically two releases, A and B, that happen near the start and end of the year. So B is end of year kind of release. And most of what I'll be showing will be relevant to earlier versions of MATLAB, the only exception being the UI, because 2012b introduces the ribbon UI in place of a much simpler UI that was available in previous versions. As far as supported systems go, there's obviously support for various desktop operating systems, though you might want to check the requirements in terms of bitness, for example. And curiously enough, MATLAB also supports mobile devices running the Android and iOS operating systems. If you want to use MATLAB from your mobile device, say an iPad, you certainly can. MATLAB has free apps for iOS and Android, and both are available on the respective app stores. And those apps allow you to connect to a desktop, shall we say, MATLAB installation. And you actually have two options here. You can either connect to MATLAB that's installed on a machine available on the network, and if you choose this option, you'll need to download another free piece of software called the MATLAB connector, which is required to allow access to that machine. And note that MATLAB needs to be running and the connector needs to be started explicitly before you're able to connect from a mobile device. There is, however, another much simpler way of using your mobile device, which is to use the MathWorks cloud. And in this setup, instead of connecting to a desktop machine, you're connecting to a machine that's hosted by MathWorks. And all you need to do is type in your MathWorks account username and password, and you're in. And obviously, in both cases, you can only use the toolboxes that you've actually got licensed. The mobile app is not standalone, meaning that you won't be able to use it without an internet connection. And what it really only gives you is a command window where you can type in commands, so there is no text editor where you can edit whole scripts. However, you can plot graphs and view them on your mobile device. However, none of the UI options that you get on the desktop version of MATLAB are available on mobiles, so you cannot, for example, customize a graph after you've generated it. The screenshot here on the right shows a MATLAB session taken from my iPad. As you can see, I've got some space on the left where I can type in commands, and I've got a graph on the right, and that's about it really. Still, it can be useful when you need to quickly calculate something or plot a simple graph. MATLAB is a highly modular product, and it's extended by toolboxes. A toolbox can be as simple as a collection of available functions that the programmer can use, but it can also include GUI-based applications that help you perform specific tasks. A lot of the popular toolboxes are actually made and sold by MathWorks, and those are licensed individually. There is also a number of third-party toolboxes that one can find out there on the web. When I refer to toolboxes, though, I'll refer primarily to toolboxes that can be bought together with the MATLAB installation. It's important to realize that MATLAB itself as a product also has functionality of its own, and in fact throughout this course we'll only be looking at that functionality that comes with MATLAB itself rather than any toolbox that's available for it. As for the toolboxes, they all serve MATLAB in a number of different directions. And first, there are toolboxes which extend MATLAB's mathematical capabilities. So, for example, if you install a symbolic toolbox, you suddenly get the ability to define symbolic expressions and then do things like, let's say, symbolic differentiation or integration of those expressions. And if you install the stats toolbox, you get all the popular statistics functions. Then there are toolboxes which are relevant to different industries or more broadly to various problem domains, such as, for example, aerospace or econometrics. And then there are toolboxes related specifically to computation, i.e. the ways that things are actually calculated. So for example, the parallel computing toolbox enables parallel code to be written in MATLAB, whereas the MATLAB compiler lets you make actual standalone applications from your MATLAB code. And last but certainly not least is Simulink, which is also integrated with MATLAB, and it's a tool for model-based design and simulation for embedded systems. And Simulink has a product family of its own for different types of modeling, and it also supports code generation for various languages such as HDL.